Hi, welcome back to McClatchy Maths. My name is Natalie McClatchy and we're continuing our 2024 playlist today for the external exams in Queensland for general maths. And we're looking still at paper 1, short answer questions, and this is a focus on networks in this video with questions 17 and 24. Now before we get into it, I want to let you know how you can engage further with us here at the channel. Firstly, you could share the link to the channel on your Class 1 note or send it on your social media or email to a friend. You could consider liking and subscribing, or even tell us in the comments if you find the video helpful. We always love to hear your feedback. And lastly, if you want to keep the channel going, you need to donate $2 to our PayPal account using your PayPal account by hitting that Super Thanks Heart button. Okay, so question 17 is worth 4 marks. This is our first question we're going to focus on today. A planar graph is shown. Define what a planar graph is, and this is worth 1 mark. Well, we know a planar graph is any graph that can be drawn or redrawn so that no edges intersect or overlap. And so what the definition was that we were looking for there is that we've used this word intersect. You didn't have to write both of them. I've just used some alternative words. You could even say that there's no edges that cross over, and that is your correct definition of a planar graph. That's all you needed to write for 1 mark. How many faces does the graph have? Now, remember, a face is an enclosed space, like a shape that's formed by the network. Okay, so let's have a look. This is our first face because it's enclosed. Our second face is the triangle here. Third face here is this triangle. Fourth face here. But remember, there's always an extra face on the outside. So this would be probably where people make a little forgetful mistake. The outside is also classified as a face. And so that means there are 5 faces on this network, and we get another mark for correctly stating the number of faces. Show that Euler's formula works for the graph, and this is worth 2 marks. So this is a kind of a proof. So first of all, we've got our formula from the formula sheet. Didn't have to memorize that. Vertices plus faces take away edges equals 2. Now with any formula, I should always define my variables. We've just found out that there were 5 faces. Let's count the vertices. These are the dots. 1, 2, 3, 4, 5, 6. So I've got 6 vertices. And edges. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is not one straight line. This extra vertex here breaks it up into 2 edges. And a loop is always classified as an edge as well. So now, because I've correctly defined my variables, I'm going to get a mark. So that's important to actually state explicitly what these things are that you're going to be substituting into your formula. And now we're going to use those numbers to prove it. So 6 plus 5, take away 9 equals 2. Well, 6 plus 5 makes 11, take away 9. 11 take away 9 is 2. 2 equals 2. Therefore, Euler's formula works for the graph. And because I've shown that with my working, I get my second mark. Let's look at question 24. The graph represents 6 students A to F. Each edge connects 2 students who study an identical subject. Doesn't matter what the subject is, they just study something in common. We need to firstly construct an adjacency matrix from the graph with the vertices in alphabetical order. That's important. And we're going to get 2 marks for this. So we need to do it properly. Okay, so first of all, I'm going to set up my matrix. I've got A, B, A, C, D, E, F vertically and the same horizontally. So I've already set up this alphabetical order. The next thing is I'm going to have this leading diagonal where everything is 0. And that's because there are no loops. There's no little loops sitting around these edges where it goes back from one to the other. So there is a 0 way of going from A to A, B to B without passing through any other edges. So I can pop that in easily there. The next thing I'm going to do my values for A to E. So that's this one here, and A to F. There's one edge between those, and that will also fill out this section here. So if I'm just going to focus on A first, and then just look at the connections for A. A doesn't go to B, it doesn't go to C, it doesn't go directly to D, so that's going to have all those zeros filled in there. And I'm going to continue on populating my matrix. So I've completely finished one row or one column in a 6 by 6 matrix with the same horizontal and vertical labels, yes and yes. So I've got my first mark. And I'm just going to continue setting this up. So as I pass through different parts of the network, I'm going to end up with this matrix right here. So I suggest you pause the video there and have a look at these connections. We might just do it for B. If I look at B, B only goes to E and C. If I come across here, C and E. And if I do that, for example, in a different one in reverse, D only goes to E and C, so D only goes to C and E, D only goes to C and E. So you can see that it's correct. Okay, because I've now fully filled out my matrix, I'm going to get a second mark. Now that moves on from the matrix, so if I got the matrix wrong, well, I've still got 3 more marks to achieve for this question. From the terms below, identify everything that describes this graph here. So I've got choices bipartite, connected, directed, simple, and weighted. And identify all indicates that there could be more than one. So I've got to get this right. So first of all, let's think about what bipartite means. This is what a bipartite graph looks like. You've got the different vertices are split into 2 columns, and there's no up and down in those columns, but there is crossways. Well, that's not a bipartite graph. Let's cross that one out. What about connected? What does connected mean? Well, connected means that every pair of vertices can be reached with a unique edge. So if I look at this graph up here, well, here's a pair of vertices, and they've got one unique edge. Here's another pair of vertices, and it's got one unique edge. And every pair of vertices can be reached. So it's a connected graph. Okay, so we've got the first one. What about directed? Well, this is what a directed looks like. It's got arrows. There's no arrows in this graph, so it's definitely not directed. Let's cross that one out. Let's look at the definition of simple. Okay, it's got no loops. Correct, there's no loops. There's only one edge between 2 vertices. Yep, only one edge. So it's a simple graph as well. What about weighted? Well, this is what a weighted graph looks like. It's got numbers on the actual edges. So they actually have values or measurements. This is not a weighted graph. We'll cross that one out. So my only possible answer is connected and simple. And because I've correctly identified that, I get the 3rd mark for question 24. Okay, let's look at part C. Identify all students who study an identical subject to student C. Now this up here is the clue. Every edge tells me who's got identical subjects. So basically I'm looking for anyone who's got an edge from C to somewhere else. So I've got here to D, I've got to E and to B. So these are my 3 possibilities. So my answer is D, E and B, and I get my next mark for correctly identifying just those 3. My final mark is to now draw and label a connected subgraph that contains student E and has 3 edges and no cycles. So that means I can't use a triangle enclosed shape because that would be a cycle. So basically what I'm going to do is pick any 3 edges that come out of E, and I could draw that. For example, if I use this one here, F, A and B, that's the one that stands out the most to me. I've now got my mark for correctly drawing and labeling a connected subgraph. So connected means that the edges all have to join to E, and that there can be no triangles in this actual subgraph. So a subgraph has to be part of this total graph. So I'm just basically eliminating sections of the graph and just focusing on E. Now I could have done this lots and lots of different ways. There are many subgraphs on there. There's a challenge for you. See how many different ones you could come up with. Well, if you've got any questions today, you could email me at mcclatchymaths@yahoo.com. You've been watching McClatchy Maths. Thank you for joining me today. Have a lovely day.